Hello again, welcome to MasterCAM course in that lecture, and we're gonna talk about 3-axis toolpath actually by using the SolidWorks part. As you can see here, some SolidWorks part is created. So I'm gonna try to create a toolpath for this product. Okay, let's get started. So actually this is the SolidWorks part. I'm gonna use the file and open options actually. At that point, actually, I also would like to emphasize that you need to turn to all files options and if you would like to see the SolidWorks part. I can also see the SolidCAM part here and SolidWorks part for this one. So after that, when I am double click on it, we're gonna see our product like this. So after that, and of course, we can rotate our product or we can transform my product according to my VCS. So this VCS is quite important. That VCS must be similar to actually my CNC machine G and 54. Okay, that's the quite important part. Okay, let's get started. I'm gonna turn to the wireframe and bounding box options. When I am click bounding box options, I need to select my entities. To be able to select my entities, I'm gonna use actually manual options. So after that, actually it's already selected. So I just need to turn to my screen and select all my solid model. And then I just need to hit end selection button. And then you're gonna see that my actually bounding box created by using the shape as a rectangular shapes. Okay. So after that, let me click here. So it is easy to create that kind of and actually workpiece. After that, I'm gonna turn to the line endpoints and then let me create some actually diagonal line like this. And then I can turn to the transform options and then move to origin. And then I just need to select my midpoint. If you cannot select your midpoints actually, you need to turn to here. This is the selection settings. And then you can organize your midpoint options is active or not. If this is not active right now, you need to select these options as well. After that, let me click OK button. And then we can add that options to our configuration file. And after that, I can turn to the transform again and move to the origin options. And then I just need to select the midpoint of my diagonal line. And after that, actually, it is easy. We just need to use the right mouse button to use actually clear color options. Okay. After the transform, master can make my product and a different color to be able to understand and which entities is rotated or transformed. So that's why we need to use the clear color sometimes. Okay, and after that, actually, we can easily turn to here. Actually, we can use actually line options. For example, I can hit that line options, select all line entities. It's already selected, as you can see, and then we can hit the delete button and then we can get rid of them all that stuff here. And after that actually, and let's start with actually face toolpath. Okay, to be able to create my face toolpath, I'm gonna turn to the 2D and z-axis 0. And after that, I just need to turn to the wireframe and I just need to click on the curve all edges button and then I just need to select that face. Or it is also easy to select this one actually and then hit OK button. When I am click OK button, we're gonna see that kind of curve is created. So after that, we can easily create our face toolpath. Okay, let me save my file. This is example 4 actually. And then let me turn to the machine and mill machine and default machine. And after that, we can use actually this button. You can see here, right mouse button, mill toolpath, and then I'm gonna hit the face toolpath. You can also select this one. This is also face toolpath. Okay, let me keep going here. And then I just need to select my boundary. This is my boundary, and then I'm gonna hit OK button. So let me continue with the tool selection. I'm gonna turn here and create my tool actually. When I am click the next button, we can easily select our tool. My tool can be 20 mm diameter, flat, end mill. And then I can hit the next button and finish button. And then we can easily create our feed rate and cutting speed. According to my cutting speed, actually, my spindle speed is calculated by using my tool diameter. And after that, we can also multiply with our fluid with my actually and the feed rate per teeth. And then we can multiply with my spindle speed, and then we're gonna get our feed rate. So according to that perspective, my feed rate and millimeter divided by mean and my spindle speed actually rev divided by mean is calculated automatically. Okay, so after that progress, actually we can also add some tool name, and we can also see our tool number. This is the magazine number in our CNC. We can also see the length offset and the diameter offset. So actually after that, let me turn to the linking parameters. When I am turned to linking parameters, we can prefer to select absolute or incremental coordinate system. And absolute coordinate system means that we're gonna focus on only our MasterCAM VCS. If you click on the incremental, it means that we're gonna focus on actually our profile. So according to my profile, incremental system that can be 0. And in our example, actually, we are working on the Z0, our profile on the Z0 position. So, and it doesn't matter and which one is selected right now. But most of the time in the face toolpath, we prefer to use absolute coordinate system. So it means that I don't care and where is my profile is selected in these options. Actually, you can also see that this is my geometry. My geometry is already selected, and MasterCAM knows that where is my profile actually. But when we turn to the linking parameters, if you select the absolute coordinate system, it means that I don't care about where is my profile. Okay? And actually, according to z-axis, I mean, x and y-axis is of course quite important, but when we consider the z-axis, and so it is not important. So I'm gonna hit here as absolute and retract 5, and absolute and fit plane 1, and this is the last point for G0. After that, we're gonna turn to G1. So after that, I'm gonna write 0. This is the top of stock, and depth also 0 according to absolute as 0. Okay, so after that, we can turn to the cut parameters. When we turn to the cut parameters, we can prefer to zigzag method. When we prefer to use the zigzag method, actually, I also would like to change my the roughing angle. When I am changed to my roughing angle, X and Y axis is moved together. So that's why we're gonna get better surface roughness. After that, this is the stock to leave on the floor. I'm gonna make them 0. After that, we can organize our step over. My step over calculated my tool diameter. This is the 50% of my tool diameter. And then we can also see here approach distance and the exit distance. And approach distance means that while we are entering our product, we can use the extra lead in and lead out approach. We can also see the across overlap and along overlap options here. That is also help us to expand our toolpath, and when we consider actually our profile. We can also turn to the high speed loops. This is the move between cuts. For example, we're gonna get the sum and toolpath on this direction, and after that we're gonna turn to this direction. While we are creating that and the transaction, actually we need to get some movement here. If this is the high speed loops and circular interpolation, I mean, so you're gonna get smooth movement. And actually, this is the main idea behind the manufacturing process, okay? Don't use sharp linear movement, okay? Try to use smooth movement because we wanna see and simultaneous cutting process. If you use the sharp corner toolpath geometry, it means that you're gonna get actually and some and actually uncut process, okay? This is not and this is not actually simultaneous, okay? You need to stop and then you need to move, so that is not good. So we want simultaneous cutting process, so that's why and prefer to use the circular interpolation, and maybe we can use the sum and the spline movement, maybe that's also quite important. So actually we can also see the cutting method, but when you select the zigzag method, and actually that's not important, but we can prefer to use conventional machining for roughing process. And after that we can also organize our depth cut, but in that example we're gonna cut and 0 to 0. So this is my cutting area, top of stock to depth. So there is no any cutting area between the 0 to 0, so that's why we don't need to give any depth cuts here, okay? After that we can also see the arc filter and planes. Plane of course must be top to top, and then coolant. If you would like to activate your coolant, you can click on button, and then you can also see the approach here, and you can also add some M function. So that's also quite important in your CNC operator. And you can add M0, M1, and M10, I don't know, and you can use that kind of and M function, okay? When we turn to here, that is organize our VCS, okay? And that is the axis progress. If you intend to use your rotary axis, you can also use that stuff. But at that point, that's not important right now. Okay, let me click OK button. And then we're gonna see that kind of toolpath. Anyway, let's create our contour toolpath. I'm gonna turn to here to create my contour toolpath. When we turn to the top view, actually, and this is actually our CNC, and then we're gonna be on this side. Okay, we are here right now, so that's why I prefer to and start from that's and entities. Okay, I'm gonna start with from here, and then I'm gonna use the same tool. I don't want to change my tool. This is my tool, so let me organize my feed rate and my cutting speed for contour toolpath. And then I'm gonna turn to the linking parameters. This is the same progress actually. We can consider and our and MasterCAM VCS, we don't care about and where is our profile. I'm gonna turn to the feed plane and top of stock 0 and absolute. When we turn to the depth, it can be this part. This is the minus 96 for my depth position. And then we can turn to the cut parameters. When we turn to the cut parameters, actually, we're going to see the compensation type. Compensation type can be seen computer, control, and control here, and the wear and reverse wear can be seen here. When you select the the computer, actually, your and the tool diameter actually calculated automatically. Okay, so it means that you don't need to write any and D offset in your CNC. Okay, if you would like to write your D offset in your CNC, for example, you can turn to the wear activation. And when you select the wear activation, it means that our tool diameter is calculated by MasterCAM, but you can also get some D offset number and you can organize and your tool diameter, for example, by using the 0.1 millimeter. So when you write 0.1 millimeter, it means that you're gonna add 20 plus 0.1 millimeter. So you can organize that kind of stuff by using the wear options. But at that point, don't forget to write and the wear parameters. Okay, you don't need to write your D parameters. I mean and you have two parameters actually. So when you turn to your CNC, one of them is diameter. If you use the wear or computer, you don't need to write any diameter in your CNC. Okay, that is calculated by the computer. If you write your wear, and so that's going to help you to organize your tool diameter. For example, 20 plus 0.5 or 20 plus and 20 and point actually 0.1, for example. And after that, if you intend to use the control, actually, when you write control, actually you need to write your diameter offset in your CNC. And also, you can also use your wear parameters. So when I am selecting control, my tool diameter is not calculated by actually MasterCAM. So this is the quite important part. So I'm gonna turn to the wear here. So when you turn to your CNC, you can easily organize your tool wear by using the wear offset number. As a contour type, I prefer to use the 2D. You can also see the different approach here. So according to my chain, let me turn to the tool type and chain geometry. We're going to see that kind of tool geometry is selected. This is my direction. So according to my direction actually, and when I am selecting wear, it means that my compensation direction can be on the left side. Left or right side can be selected. So this is my chain actually. It's an arrow. And then we're going to be on the left side. So I think that's it. And then we can turn to the depth cuts and activate our depth cut, and then I can make them 5 millimeter maybe. This is the depth cut order, and actually if you select the and more than one chain, you can consider and that's parameters as well. Okay, so I don't want to create any finishing and process actually. So we can turn to the lead-in parameters. So when we turn to the lead-in parameters, actually, we're gonna see the two parts. So this part is lead-in and this part for the lead-out process. When we turn to the lead-in process, actually, we're gonna see the two and the main entities. One of them is line and the second one for arc. If you intend to use the line, you need to write your distance actually according to your tool diameter. For example, I'm going to click here 0. It means that I don't want to use the inner line. So after that, we can write your arc diameter. My arc diameter is going to calculate it by my tool diameter, and then this is my sweep degree. My sweep degree can be like this. So this is the half of the diameter actually. If I am hit that button to make similar my lead in, and then this is my lead in and this is my lead out, and the both of them is the similar. It means that we're gonna get some circular actually lead in and lead out process. You can also use the different approach here. For example, you can change your and the feed rate, because you know that lead in process is quite and can be quite difficult most of the time. So you can break your tool. So lead in process is quite important. So you can easily organize that stuff if you want. Okay? All of them is okay right now. I just need to hit OK button. So maybe you can think that, oh, that is, and that's not necessary actually. So you can easily turn to here and lead in out parameters, and you can make them 20. Okay? And 4 millimeter, oops, sorry, 4 millimeter and toolpath can be seen in our lead in process. Okay, cool. Anyway, this is the actually face toolpath and contour toolpath in MasterCAM. Let me save my file.